Microphone on. Okay, so now let's take a look at doing some half-life problems. So with half-life problems, I want you to start all of them with a T-chart. So this chart always will start out with the amount on the left and time. And under time, you're always going to put a 0 because this is where you're starting the stopwatch right now at time 0. Now you're ready to read the problem. So number 1, it says the half-life of radioactive strontium is 28 years. How much of a 100-gram sample remains radioactive in 112 years from now? So the amount right now when I start my stopwatch is 100 grams. The amount side, you're going to chop in half every time. So 100 in half is 50. 50 in half is 25. 25 in half is 12.5. 12.5 in half is 6.25. And of course you could keep going, then it would be 3 and so on. On the time side then, 0 always goes in the first slot because this is always right now at time 0. So the half-life really is how much time has passed when half of your radioactive sample has decayed. So your half-life will always go in that second slot. On the half-life side, on the time side, you are adding 28 years every slot. So from 0 to 28, another 28 years goes by, so 28 and 28 would be 56. Another 28 years go by, that would be 84. And another 28 years go by, brings you up to 112. So in 112 years, I would still have 6.25 grams left. And if you set up these charts, every time you have a half-life problem, you'll never have the wrong answer. So let's take a look at number 2. We'll do this one over here. We've got amount and time, and I put a 0 in this first slot before I read the problem. So problem number 2 says that I have a 60-gram sample. It decays into a 15-gram sample. So right now when I start my stopwatch, I always put a 0 in this first slot, is at 60 grams. 60 in half is 30. 30 in half is 15. And next to 15 grams then, they're telling you you have 3,200 years. So with these half-life problems then, to figure out the half-life, you just count how many half-lives you've undergone. So I've undergone 1, 2, so I divide this by 2, and this becomes 1,600 years. So again, as long as you put a 0 in here, you're counting this would be the first half-life, this would be the second half-life. So that's why I take that half-life and divide it by 2. I've undergone 2 half-lives, so if I divide by 2, I end up with how much my half-life is. Okay, let's try another one. So in number 3 then, it says the half-life of phosphorus-33 is 25 days. So how much of a 40-gram sample remains unchanged in 100 days? So again, we're starting up our chart. We're going to say that this is still the amount and the time, and I would put a 0 here. And I would say how much of a 40-gram sample, so I started out with 40 grams at time 0. Chop my 40 in half is 20. I'm just going to move this up here just a little bit. Okay. 20 and a half then is 10. 10 and a half is 5. 5 and a half is 2 and a half. I don't know how long we'll have to keep going. All right. On the time side then, you always put a 0 in the first slot. The second slot is always your half-life. So in this case, it's 25 days. In the next slot, another 25 days go by, which is 50. The next slot, another 25 days go by, which is 75. The next slot, another 25 days go by. Now I'm up to 100. So I've really undergone 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives. Or you could say your half-life times 4 would be 100. So next to that then, notice you have 2.5 grams is what you have left. Oh, I guess I don't need an arrow there. Okay? All right, so let's keep going. All right, so number 4 then says, I have a 40-gram sample of a radioactive substance. It decays into 5 grams in 100 days. So off to the side here again, my amount, my time, my 0, and it says I have a 40-gram sample. It decays into 5. So 40 and half is 20. 20 and half is 10. 10 and half is 5 grams. And those 5 grams, next to it you have 100 days. So how many half-lives have you undergone? You've undergone 1, 2, 3. So if I take 100 and I divide it by 3, I end up with 33.3 repeating, right? 100 divided by 3 would give me 33.3333. So my next half-life, my second half-life, would be another 33 years. That would give me 66.6. And my next half-life would give me another 33.3, which would give me 99.9, which that's close enough to 100. So here, my half-life then would be 33.3 days. Okay. Number 5 then, I'll set up my chart before I even read it. Amount, time, 0. Now I'm ready to read my problem. The half-life of cobalt-60 is 5.3 years. Now notice I didn't put that in the first slot because this is when I start my stopwatch at 0. So after the first 5.3 years go by, that's the half-life. So that really always goes in the second slot. How much of a 500-gram sample remains unchanged after 21.2 years? So my 500 grams goes over here. All right, so I have 5.3 plus another 5.3 days go by. That would be 10.6. So my next slot would be 10.6. I add another 5.3 onto that. That gives me 15.9, right? 15.9, and another 5.3 days go by. Now it looks like I'm up to the 21.2. So notice I've undergone 1, 2, 3, 4 half-lives. So my original sample's got to be chopped in half 4 times. 500 in half is 250. 250 in half is 125. 125 in half is 62.5. And 62.5 chopped in half would be what? 31.25. So that would be my final answer, 31.25 grams. Okay? All right, my final question then, it says the half-life of iodine 131 is 8 days. So how much of a 200-gram sample would remain in 40 days? Okay, so here we go. I'm going to start out with a 200-gram sample for my amount on the side at time 0. When half of it decays, 200 and half is 100. 40 days go by. Nope. 8 days go by. Correct? All right. 100 in half is 50. And another 8 days go by. That would be 16. 50 in half is 25. Another 8 days go by, and that would give me 24. Yep. I got to get up to 40. Another 8 days go by, which would be 32. Yep, 32. And that would be 25 and a half, which would be 12 and a half. Finally, I think, another 8 days go by. Now I'm finally up to 40. So notice, remember, this was amount, this was time, and I put a 0 in the first slot next to the 200. And chop this side in half. 200 in half is 100. 100 in half is 50. 50 in half is 25. 25 in half is 6.25 grams. On my time side then, notice I started out at time 0. Right now I started the stopwatch. My half-life always goes in the second slot, 8 days. Another 8 days go by is 16. Another 8 days go by is 24. Another 8 days go by is 32. Another 8 days go by is 40 days. Okay? So now on the next page then is the balancing nuclear equations, which you can try. And then the page after that is another page of half-life problems. So you can try those. All right, good luck.